before I upload videos on section 3.2, I would like to finish off with section 3.3 because that's a small section, and I just want to break the monotony and complete a section with just recording a video. Okay, so this section is all about dividing polynomials. You will learn many two methods to divide one polynomial by another polynomial. So that is, one method is long division of polynomials and another one is synthetic division. And you also learn some theorems, that may be the remainder theorem and the factor theorems, and you will learn how to use these theorems to analyze maybe roots or certain concepts, mathematical concepts, that is, and solve few problems using the remainder theorem and the factor theorem. So to divide, state the division algorithm, if p of x and d of x are polynomial functions, are polynomials, and d of x is not equal to 0. This is very important. In a fraction, you cannot have the denominator to be 0, that is undefined. Then there exists a unique polynomial. This is the symbol for there exists unique polynomial q of x and r of x, where r of x can be either 0 or it should definitely be of degree less than the degree of d of x, such that if you divide p of x divided by d of x, you can express that as the form of q of x plus r of x divided by d of x. Okay, or this particular equation can also be written as p of x is equal to d of x q of x plus r of x. So that is cross multiplying d of x with the terms in RHS. So where p of x is called as dividend, and d of x is called as divisor, and q of x is called as quotient, and r of x is the remainder. Okay, so this is we have established the long division of polynomial method. So using long division method, we can divide a polynomial by using another polynomial, which is nothing but the divisor. So, and whatever remainder you get, you can express it as this equation by using the division algorithm. Okay, let us do a problem of long division. So I will do an exercise problem. So that this is problem number 8 in the book, which says that there are two polynomials p and d that are given. So let me see which are the polynomials. P of x is equal to 2x power 5 plus x cube minus 2x square plus 3x minus 5. Okay, so and d of x is x square minus 3x plus 1. So we use, they have given it to be used either synthetic or long division, but I have just taught you long division method, so I will do this problem using a long division method. After I teach you the synthetic division, let us do some other problems using synthetic division method, and express the quotient p of x divided by d of x in the form of this, like the one that we stated in division algorithm. Okay, to do the long division method, so I will consider 2x to a power 5 plus x cube minus 2x square plus 3x minus 5. and our dividend is x square minus 3x plus 1. So what should we multiply with x square to get 2x to the power of 5? So that we will write in the quotient. That would be 2x cube, right? So multiply 2x cube with all the terms of the dividend, then and write it below the polynomial. So this would be 2x to the power of 5 minus 6x to the power of 4 plus 2x cube, correct? So now do the proper division process, that is subtract the upper row by the lower row. So this is 0, but here you have 6x to the power of 4 and x cube, so they are not like terms, so then retain it below as it is. So 6x to the power of 4 plus x cube, and this one is okay, negative this is x square and x cube, so again they are not like terms, so retain those terms as it is. 2x cube negative, sorry, yeah, because we have negative 2x cube minus 2x square plus 3x minus 5. So now do the same process again. Which is the number that you should multiply with x square to get 6x to the power of 4? We should multiply it by 6x square, right? So plus 6x square, and multiply 6x square with all the terms of the dividend. Then we will be getting, and write the polynomial that you get below this particular polynomial. So we will be getting, okay, yeah, we will be getting 6x square times x to the power 6x to the power of 4, and negative 3x times 6x square will be negative 18x cube. Okay, have I missed something? Okay, so yeah, before doing this, we can see 2x cube terms here. So that is x cube minus 2x cube. So that this can be written as 6x to the power of 4 minus x cube minus 2x square plus 3x minus 5. Okay, so now we shall do the process that we were doing before simplifying. So that was 6x square times x square will be 6x to the power of 4. 6x square minus 3x is minus 18x cube. Okay, and 6x square times 1 is plus 6x square. So now subtract the terms. This term will get cancelled, and you have the plus sign here, minus sign here, and the rest is as it is. So plus 18x cube minus x cube is 17x cube, minus 2x square minus 6x square is minus 8x square, and plus 3x and negative 5 retained as it is. Now to get 17x cube, what should you multiply with x square? Write it in the quotient. So that would be 17x, correct? So you get 17x cube. Okay, then 17x times negative 3x is negative 51x square. Okay, and plus 17x. So again simplified further, plus 17x cube and minus 17x cube will be cancelled. This will be plus sign and this will be negative sign, and plus 51x square minus 8 will give you 43 plus 43x square, and minus 17x plus 3x will give you negative 14x minus 5. So now what should you multiply with x square to get 43x square? So it is just 43. So multiply by 43. So this would be 43x square. 43 times 3 negative 3 is 129 minus 129x, and 43 times 1 is 1 itself. So write it as plus 40. Sorry, 43 times 1 is 43. Yeah, plus 43. So now subtract the terms. So this will get cancelled, and the second term is 129 minus 14x. They are like terms because there is x on in the both the terms. So 115x minus 43 minus 5 is minus 48. Yeah, minus 48. So this has a degree which is below less than the degree of the dividend, so further division is not possible. So now they have asked us to express it in terms of this equation that we learnt in the division algorithm. So our p of x is p of x is 2x to the power of 5 plus x cube minus 2x square plus 3x minus 5, and d of x is x square minus 3x plus 1, and our q of x is, we calculated the quotient right now, so it is 2x cube plus 6x square, 2x cube plus 6x square plus 17x plus 60, is it 60, 43, okay, 43, and d of x, what else we need the remainder. So r of x is nothing but 115x minus 48. So using the division algorithm, p of x divided by d of x is equal to q of x plus, correct, plus r of x divided by d of x, or I can write it in terms of the second equation, p of x is equal to d of x q of x plus r of x. I will use that. P of x is equal to d of x q of x plus r of x. So this will be nothing but 2x to the power of 5 plus x cube minus 2x square plus 3x minus 5 is equal to d of x is x square minus 3x plus 1 times q of x is 2x cube plus 6x square plus 17x plus 43 plus r of x is 115x minus 48. So this is how we do the division process. So we will learn another method of division, that is synthetic division method. So synthetic division method is a method that I will be teaching now. So instead of performing long division, this is very simple and you can very easily get the quotient or the remainder just using the coefficients of the division, coefficients of the polynomial. So suppose you are asked to use synthetic division method to divide 2x cube minus 7x square plus 5 by x minus 3. Okay, so you will write the coefficients of this in terms of the order, that is coefficient of x cube is 2 and coefficient of x square is minus 7, coefficient of x is 0. So you have to cover all the powers from 3 to 0. So you will get this is the coefficient of x cube, this is x square and x, and you have 0, correct, that is x to the power of 0, that is 1. So what is the coefficient of x to the power of 0? It is 5. Okay, so then which is the term which is the constant coefficient of x minus 3? What is the constant in x minus 3? That is 3. So this is of the form x minus c. So you have to take this C value and put it up here. Okay, so then draw a line horizontally, leaving some gap in between the above column, above row. So then you multiply 3 with take 2 below the first term below the row, and multiply 3 with 2 and put that product below -7. So that would be 6. Okay, so then apply the add -7 and 6, add this process, add these two numbers, so you will get -1. Now multiply 3 and -1 and put the product below 0, so you will get 3 times -1 is -3. So then add these two terms, add, so that would be -3 itself. Repeat the process, multiply 3 with -3, so that is -9, and put the product in below 5, that would be -9, and add 5 and -9, that would be -4. Okay, so you have you use these two terms, these three terms, to express it like you have the degree to be equal to 3 here, so you will start from 2, degree 2. So our quotient will be 2x square, that is this particular term will be the coefficient of x square, this will be the coefficient of x, and this will be the constant, and this is nothing but the remainder. Okay, so quotient will be 2x square minus x minus 3, and r of x is -4. So if you have to express it using the division algorithm, 2x cube minus 7x square plus 5 is equal to x minus 3, that is our dividend, times 2x square minus x minus 3 minus 4. So this is our final solution. Okay, so I will do another exercise problem. This was an example problem, so I will do an exercise problem for you that is using synthetic division. Maybe I will do number 47. Yeah, 47 is a part of your homework problem. Okay, I will do, yeah, I'll do 40. Okay, it's no problem, I'll do number 47. So this is p of x is equal to x to the power of 7 minus 3x square minus 1, and c is equal to 3. So you are when you are given c is equal to 3, it means that you are asked to divide the given polynomial by x minus 3. So let us write all the coefficients of x to the p of x from 7 to 0, from degree 7 of x to 0. So that would be 1. Yeah, that would be 1 of x to the power of 7, and 0 of x to the power of 6, 0 of x to the power of 5, 0 of x to the power of 4, 0 of x to the power of 3, then -3 of x square, and 0 of x, and -1 is the coefficient of x to the power of 0. Okay, then you are asked to divide it by c is 3, so divide by 3. So I asked you to draw a line leaving some gap. So bring down the first number, that is 1, multiply 3 by 1 and put it under the 0, that would be 3, add 0 and 3, you get 3, multiply 3 by 3, you will get 9, put it under the next 0, add 0 and 9, it will be 9, multiply 3 and 9, you get 27, put it under the next 0, so that would be 0 plus 27 is 27, multiply 3 and 27, you get 81, so add 0 and 81, it will be 81 itself, then multiply 3 and 81, you get 240, correct? Okay, yeah, sorry, 243, 243. Add negative 3 and 243, you get 240. Multiply 3 and 240, you get 720. Put it under 0. So 0 plus 720 is 720 itself. And multiply 3 and 720, you get 2160. 2160. Add negative 1 and 2160 is 2159. So what the thing to just make sure that you got all the numbers, all the coefficients right. So if you have 7 degree, you will get if you have nth degree polynomial given, so that is if your p of x is an nth degree polynomial, the number of coefficients that you get will be n itself. Okay, so that is except remainder, the rest you will have 6 numbers, that is n minus 1 numbers as a coefficient. So now expressing this as our q of x will be, this 1 is the coefficient of x power 6, and 3 is the coefficient of x power 5, and 9 is the coefficient of x power 4, plus 27x cube, plus 81x square, plus 240x, plus 720. So this is our quotient, and our remainder is 2159. Okay, so yeah, so 2159. So if you have to, I think you can use the division algorithm and express it as p of x is equal to q of x times d of x plus r of x. So p of x is given, it's a very long term, I can't write it. So p of x and q of x are quite long, and d of x is x minus 3. So you have to identify that using your c value, plus r of x. R of x is 2159. Okay, the rest you can write the p of x and q of x seeing the values here and the question. Okay, let us move on to the next theorem, that is as promised by me in the beginning of the video. So what is that? That is remainder theorem. So remainder theorem says that if a polynomial p of x is divided by x minus c, then the remainder is the value p of c. The remainder is the value p of c. Okay, so in the above problem we had p of x to be divided by x minus 3, right? And we got the remainder to be 2159. Okay, so using the remainder theorem, it says that p of 3 is nothing but, where c is 3. Okay, p of 3 is nothing but 2159. We can verify this using substitution method. That is, our p of x was it was quite a long okay, our p of x was x to the power of 7 minus 3x square minus 1, correct? So p of 3 would be 3 power 7 minus 3 times 3 square, that is 9 minus 1. So let me find out what is 3 to the power of 7. So 3 to the power of 7 is 2187 minus 9 3s are, it is 27 minus 1. Okay, 2187 minus 28 is 2159. So what the remainder theorem says is perfectly alright. So this is how you find out the remainder theorem to find the values p of 3. Okay, we learn another theorem, that is the factor theorem. So the factor theorem states that c is a 0. That is, what do you mean by a 0? It is a root, that is when you substitute c value in the polynomial, you get it to be equal to 0 after simplification. So then c is called as a 0. C is a 0 of p if and only if x minus c is a factor of p of x. So this is very simple using the using the division algorithm. That is, division algorithm says that p of x is equal to q of x times d of x plus r of x, right? So I don't want things to be so messy. By the end of the day, I lose energy and patience. I'm sorry for that. Okay. P of x is equal to q of x times d of x plus r of x. So suppose you substitute p of c is equal to q of c d of c plus r of c, correct? So p of z is 0. Okay. Yeah. Okay. You can't prove that using... can you? Yeah, p of z is 0. And there is a perfect division. So if this p of c is 0, that means you are dividing the polynomial by x minus c. Okay, and there is a perfect division, therefore the remainder is 0. So you just have q of c times x minus c. That means these two are factors of p of c. So it is very clear by this. Okay. So that is how they have proved the theorem in the book. So using factor theorem, we shall do a problem. Okay, let's stroke eraser. Yeah, I don't know why it's taking time to erase. Okay. Yeah, I will do an exercise problem itself. Let p of x is example problem itself. So factoring a polynomial using the factor theorem. So the theorem that we learned right now. So p of x is equal to x to x cube minus 7x plus 6. Show that p of 1 is equal to 0. So by factor theorem, when this will be equal to 0, only when x minus 1 is a factor of x minus 1 is a factor of p of x, correct? That is, x minus 1 divides this polynomial by perfectly without the remainder being 0. So, or we can substitute p of 1 in the equation, so that you will get it as 1 minus 7 plus 6. So that would be negative 6 plus 6 is 0. Okay, and by factor theorem, this implies that x minus 1 is a factor of p of x, correct? So x minus 1 is a factor of p of x. So by using synthetic division or by the long division, we can see that p of x, which is equal to x cube minus 7x plus 6, can be represented as x minus 1 times x square plus x minus 6. You can verify this by doing a long division method or synthetic division method. And your the second term, that is the quotient, is nothing but you can split the terms as using the trial and error method that we learned to solve or simplify the algebraic expressions. So this can be written as x minus 2 times x plus 3. So this is how we use the factor theorem that we learned before solving this problem. Okay, this completes section 3.3 of the book. I will be back with more videos on modeling the functions because some of you came to my office and asked me to solve few problems on modeling functions that was there in 3.1. So actually that is pretty easy because you just have to convert the word problem into a function and use maximum and minimum method, like methods that I taught you in the previous video, to find out the maximum value of a function or a minimum value of a function. Okay, I'll do that video soon after this video, and I will complete 3.2 and 3.4 as well by tonight. Thank you.